Hello everyone, I'm Chris McIntosh. I help teach the statistics courses. This week we're going to go over your week 15 computer assignment. The week 15 assignment objectives are to conduct a logistic regression in Jamovi, interpret the results, and write the output or write up the results for logistic regression. This week, since we didn't have logistic regression in either the Heavy or the Navarro text, I went looking for another data set that we could use, and I found something on Kaggle. Kaggle is a data science website, and they had something with some study data, and so you should find a framingham.csv file that was provided for you, and so we're going to take a look at that. So I'm going to open up Jamovi. Give that a second to open. And we're going to go to the hamburger menu and open and browse and navigate to the folder where you've downloaded that, and you see I have this Framingham CSV. And as I do that, I notice that I did not update this text on this slide. Okay. All right. So I actually have not been through this data set yet at all. So we will be running through this together. All right, let's see what the next step in our assignment is. This is going to have the week 15 checklist by the time you look at it, and these steps will be on that checklist for us to use. Okay, so we're going to do answer the questions in section 1, study information. So I went to this Kaggle website here, and I gave you the link, and I'm going to open that up really quick, and we can just take a peek at that. So from reading, the study purpose here was to understand, this was in the introduction part, understand the early prognosis of heart disease to aid in making decisions on lifestyle choices. And the research questions was here in the introduction part, and basically, what are the most relevant risk factors for heart disease, and what is the overall risk factor for heart disease? We'll see what we can learn about that as we go through this study design. So under data preparation, this data came from this online source, and they say that it's from an ongoing cardiovascular study on residents in the town of Framingham, Massachusetts. And I did do a quick Google search and came up with this .org website for Framingham Heart Study. I'm assuming that it is related to that. I did not go searching through the information, but I did skim that website briefly and found a manuals of procedures. So those may be places to locate that. You know, like we talked about, if this was a real study, and this actually is a real study, then these would be published somewhere. There may be papers published about this study that we could look up, but we're not going to take the time to do that right now. Okay, answer the questions in section 2, data set information. So this is the part where we're going to take a look at the variables in this data set. I am seeing this for the first time while I'm recording this, and we can see we have these variables, and I understand when I read this that there was quite a few observations. So 4238, so 4,200 rows here. This is a pretty big data set, and I think there was something like 15 variables. But let's take a quick peek at what the variables we have. Our first step, like always, to go through and make sure that we know the variables and levels of measurement, and those are set correctly in here in Jamovi. We'll see how good Jamovi did at guessing the level of measurement. So male, there is, I'll bring this over, a bit of a code book here on this page. If you scroll down the page and hit the view more, and you'll see they do give us a general description of these things, and it kind of relies on you to understand some of the conventions of how things get set up. So we'll take our best guess here. So you'll see this sex, male or female, nominal, and they're identifying the level of measurement. That's handy in case you have a question. And although you'll notice they're coded with ones and zeros, and they did not give us what code means what. So typically when they name a variable, whatever attribute that is naming, something that has that attribute gets a 1. If it doesn't have that attribute, it gets a 0. So let's go ahead. It's set as nominal using integers, and let's just enter some labels in here. Like I said, we'll see how these results turn out, and but the labels will make things a lot more interpretable on our output rather than us trying to remember what these codes are in our heads. So we go to age. This says nominal. I'm pretty sure there's years of age, so that's going to be a ratio level of measurement. Let's switch that to continuous. Education. See if we can find an education. Okay, I only see one reference to education on here. Not exactly sure what education level goes with, but I'm going to guess that's an ordinal level of measurement. So let's switch that to ordinal. So that'll be something we could look up. But they didn't give us a good thing in the code book for that. So current smoker, we're going to assume that 0 is a no, 1 is a yes, and that's nominal level of measurement. That is correct. And cigarettes per day, we have a number of different levels here, and we're going to count that as a ratio level of measurement. So we'll switch that to continuous. Blood pressure meds, we have 0, 1, so we'll say 0 is no, 1 is yes, they're on blood pressure meds. Prevalent stroke, let's see if they tell us what that is. Prevalent stroke, whether or not the patient had previously had a stroke. Okay, so 0 for no, 1 for yes. Nominal, that's good. Prevalent hype, I'm guessing that's hypertension. Prevalent hype, whether or not the patient was hypertensive. So we'll say 0 is, that's nominal, that's good. 0 is no, 1 is yes. Diabetes, We'll say 0 is no, 1 is yes. Total call, I'm guessing that's total cholesterol. Total cholesterol level, continuous. So that is continuous. If I had the notes, I'd put the levels, put the units in there. Systolic blood pressure, that one's continuous with decimal places. That's set correctly. Total cholesterol, systolic blood pressure, those would both be ratio level of measurement. Diastolic blood pressure, continuous, that would be ratio level of measurement. BMI, made from height and weight, that's continuous, that would be ratio level of measurement. Heart rate, continuous, that would be ratio level of measurement. Glucose, that was also continuous, that would be ratio level of measurement. 10-year CHD. Okay, our outcome variable is the 10-year risk of coronary heart disease. Binary, 1 means yes, 0 means no. So I'm guessing that they got heart disease within 10 years of this measurement. Let's just put those labels in there. No. Yes. All right. So we got variables and levels of measurement added to our Jamovi. Data accuracy. Let's get some descriptive statistics. Okay. Oh, I forgot to put, let's go to analysis, exploration, descriptives. Let's put your name here at the top of the results. Okay, and let's do the categorical and the continuous variables separately. So let's do the categorical variables first. Let's go to click on our descriptives here, and males categorical. Education, we're going to say is categorical. Current smoker. And you can see the little symbols here. This is where the symbols are handy. So we can see all the categorical variables and the continuous ones. So we can just drag these categorical variables over to the box. And all right, that looks pretty good. Let's get frequency tables because these are categorical variables. We do not care about the mean and the median. We don't care about the standard deviation, the minimum and the maximum. And then plots. The correct plot for categorical variables is a bar plot. All right, so the number of observations for each of these. So you'll see they're not all exactly the same. That's a good tip off that these are not totally fabricated data. They may be fabricated data, but they're not all exactly the same. So no real study is perfect. So that's not too surprising. Missing values. So it looks like 4238 is our max because there's no missing there. So education's missing for 105 individuals. Blood pressure meds is missing for 53. The rest of them don't have any missing data. Frequency of male. So we see we have two groups, male and female, and we have our counts for each one. 57% female, 42.9, 43% male, basically. Education, our categories 1 through 4. Frequencies of current smoker, yes and no. And diabetes, yes and no. Frequencies of prevalence, hypertension, yes and no. Blood pressure meds, 97% no, 3% yes. Prevalent stroke, most of them no, 99.4%, 0.6% yes. And 10-year chronic heart disease, 84.8% no, 15.2% yes. So, we obviously don't have any weird categories in here, no mistyped categories. These all look pretty reasonable. These bar charts let us see, how things are divided up. So that looks pretty good. So let's get the continuous variables. So we'll go to analysis, exploration, descriptives again. You'll see it goes down and we get a new window, and now we can take the continuous variables and drag those over. Go ahead and use the arrows for those. Okay, I think I got them all. We will get means and standard deviations, and let's get a normality test on all of them. And the plots for continuous variables are going to be histograms and box plots. All right, so cigarettes per day, we have some missing data. Total cholesterol, we have some missing data. Blood pressure, diabetes, BMI, a few missing, not many. Heart rate, 1 missing. Glucose, 388 missing. So there's still pretty comprehensive data here. So you see most of these are not normally distributed. So that would be an issue using the raw data for many of these. We're not going to worry about it. Let's just see what the box plots look like. So age, some younger people, and then we're hitting there in the 30s, and they kind of drop down as they get older. No outliers from the box plots. Cigarettes per day. Definitely some outliers, some heavy smokers in this set. Most of them were zeros. Total cholesterol. Got some outliers in here. Systolic blood pressure. We've got some high-end outliers. Diastolic blood pressure. Some upper and lower end outliers. BMI. We have outliers in there. Heart rate. Got some outliers in there. Glucose. Definitely have outliers in there. So that's good to look at. We're not going to worry too much about fixing these. There are things you can do when you're violating assumptions, and mostly it's transforming data. So you use a mathematical function and transform these, often like a logarithmic function. When you have a lot of outliers like this, we're not going to worry about it. We're just going to run an example logistic regression, because we're not going to dig that deep in the weeds here, but good for us to see where these challenges lie. So we would actually do some data manipulation here. We'd probably transform some of these continuous variables, and we would just note that we have some missing data and our outliers and where they are, and correlations. Let's go ahead and get a correlation matrix for these continuous variables, because multicollinearity is still a concern in logistic regression. And so I don't know, we're not going to use all of these for our example, but let's go ahead and just take a peek at a correlation matrix. So let's do correlation matrix, and Let's get correlations between these continuous variables, and flag the significant correlations, and let's get a correlation matrix plot. We haven't looked at one this big, so this will be a good example. And all right, as we look at these, probably easiest to start with the columns and just work our way down with age. So you'll see, even though this first one, cigarettes per day, 0.193 is a fairly weak correlation, you'll see it's statistically significant. Not surprising, we have 5,000 rows of data here, so even small relationships are going to be statistically significant. Although heart rate, between age and heart rate, that's really small. That's not statistically significant. Remember, when we're concerned about multicollinearity, we're really looking for correlations of 0.8 or above. And just skimming through this table here, I am not seeing any correlations. So there's our highest one so far: systolic blood pressure, diastolic blood pressure, 0.784. That's pushing the limit of what we want for multicollinearity. So that'd be my one I'd be concerned about including both of those in a regression equation. That's good to note. Let's take a peek at the plots, and you're not going to see anything hugely specific here, other than you can get kind of a general trend because there are so many data points. You can see where they are, but interesting to look at. So yeah, that's good. That's good little exploration on our data set. And so I think that all looks pretty good. Okay, and then we're going to move in to the model overall. So I'm going to go ahead and stop this video right here. This is going to be done in a couple parts, but for data exploration, I think we've got this set up. I would say let's go ahead and save these data that we have done up to this point. File, save as, browse, make sure we're going to the right place, and Framingham OMV. Call it cleaned. That's good. All right, so yeah, save your data set where you're at. Since we went through this work to do this exploration and make sure that these were set up, you want to definitely save that. And I'll see you guys in the next video.